Hi everyone, Miss Angela here. So today we are going to do our STEM activities, which our topics today are floating and density, in particular liquid density, with some solid density too, I guess. So let's talk about what your challenge is for today. The first thing, I want to kick that off. So you'll need aluminum foil, and you can choose the size that you want. It would be kind of fun to be able to see how the experiment is affected by what size you pick of your aluminum foil. You can make it half of this, you can make it a little bit bigger, but what you're going to do is make a boat, something that'll float out of your aluminum foil. Once you do that, you're challenged to see how well you made that boat by putting pennies on your boat. Count and see how many you can put on there. Like I said, changing the size of your aluminum foil will also probably dictate how well it floats. It may not. That's the challenge. So that's what I need you to do, is to get aluminum foil, make some sort of flotation device, something that'll float, boat, and then start putting pennies on it once it's on the surface of the water to see how many pennies it can hold, and see if it varies on the size and the shape and what you make, how you make your boat. Okay, so that's your home challenge for today. What we're going to do together in our video here is our science experiment, and it is on liquid density. Okay, so density is how much matter is packed into a substance, whether it is a solid, liquid, or gas. Those are the three states of matter, right? Okay, so all types of matter have atoms. Okay, and depending on how packed those atoms are in there, how big the atoms are, okay, it will depend on how dense, how heavy something is. Okay, and so today, to show that, we're going to do an experiment with liquid density. So what we're going to need, and we're going to, I'll give it to you in order here, but the first thing we're going to need is some sort of glass container, okay, that you can see through, that you can be able to see the different layers, okay? And then what you'll need is honey, corn syrup, soap, dish soap, water that is colored, okay, I chose red, vegetable oil, and then you will need rubbing alcohol, and you'll want to color that one as well. So I colored mine green to be different from my blue dish soap and my red water, okay? You will also need food coloring to be able to dye the different liquids that you want to be able to see. And then I just have various things that I'm going to put in the, when we're done, we'll see how these solid materials, how they respond in our mixtures, okay? Or well, actually, are they gonna mix? We'll find out. All right, so wanted to show you these things. I'm going to set this up to where we're focusing on our glass cylinder here, okay, to be able to see the experiment better. So we're gonna do that next step. Okay, so what I've done is set up our experiment here, and the first thing I did, I went ahead and put in our first liquid, which is honey. You can see that it's sitting there. So let's go to our next liquid, okay, which is corn syrup, okay? So I want to just put it right there on top. Okay, I'm gonna make it about the same amount. You want to try not to get it on the sides, okay? So let's give it a second here. Okay. So one sitting on top of the other, because they because of the pouring of the corn syrup, they did mix a little. We'll give them a second to separate, and then we will move on to our next liquid. Okay, so we have our honey and our corn syrup, okay? And they are separate. They did not mix. So when I said mixture earlier, that was not correct. We are not mixing. They're stacking on each other. So our next liquid is dish soap. So it is sitting there on top of the corn syrup. See that? It's not mixing, not penetrating in. Okay, so we have 3 layers so far. Okay. See that? Are they mixing? No. Let's move on to our water. Okay, let's see what the water does. So why aren't they mixing? It's the density. Okay, see what's happening here. We get a little bit of bubblage because we did put dish soap and water together, but are they mixing? No. Okay. Put too much water in there, but you can see the different layers for sure. Okay. All right, the higher density liquids are on the bottom. We're getting lighter as we go up, lower density. Our next liquid, vegetable oil. Now last week's stem we saw that oil and water do not mix. So again, we'll have separation here. We may need to give this one a few minutes because it does have some bubbles. But you can see that the water and the oil, I mean there's some bubbles in there. Okay. They are not mixing. See that? Okay. Let's give the oil and water a second and we'll come back for our last liquid. All right, it's settled down a little bit. It still has a little bit of red tinge to it, but you can see that they are not mixed. Our last liquid, rubbing alcohol. And remember, we dyed it green. All right, let's give it a second. Did you see when I poured, it did go down into the other liquids, but came right back up? You see that? Okay, so already we have separation going on. Okay, let's give this a second to fully separate, and then we'll come back together and see the finished product. So, an interesting thing happened when I allowed these things to settle. The alcohol, rubbing alcohol that I used, is 70% alcohol, but 30%, from what I can tell here, is water. So it was a watered down alcohol. So it created a problem for this experiment. Instead of the alcohol sitting on top of the oil like it's supposed to, water molecules seek out other water molecules, as we had talked about before. And so it made its way down to the water. So that's why the water portion of this is so much bigger. So the oil's in there too, and you can see the different layers though. You can see that we have honey, the corn syrup, the soap, a large portion of water and alcohol, and then the last part that was supposed to be second to last, our vegetable oil, actually settled on the top. So that's what happened with this experiment. Okay. So when you do this, make sure you have 100% rubbing alcohol. I did not, mine was watered down. It affected how we did this experiment. But you can still see at least 5 layers here. Okay, 1, 2, 3, 4, 5. Okay, so here we are. Let's go ahead and put some items in here, some solids, and see how they respond in the tower here. Okay, so our liquid tower. Let me grab some things here. Okay, all right. So let's do a bead first. All right, just a plastic bead. Let's see what it does. Okay. It has stayed sitting on top of the dish soap. Okay. All right, let's try something else. Let's try a marble. Okay. Where did it go? Oh, it went down to the bottom. Okay. Sitting on top of the honey. Or not even the top. It's trying to make its way even further down. All right. Let's see what else we have here. I have a styrofoam ball. Let's see what happens with it. It just sits right on top of the oil. Okay, so what is happening here in terms of floating and the ability of floating? Okay, so let's talk about that for a second, because it also applies to your boat. Okay, so the science of floating was first studied by the Greek scientist Archimedes. He figured out when an object is placed in water, or any liquid, I guess, when an object is placed in water, it pushes enough water out of the way to make room for itself. That's called displacement, okay? So when you get into a tub, the water rises to make room for you. Because the downward force is gravity, the upward force is buoyancy, okay? So an object will float if it weighs less than the amount of water it displaces. An object will float if the gravitational force is less than the buoyancy force, okay? So, it also has to do with the amount of atoms, the amount of matter that's inside of something. So even though our styrofoam ball is bigger than our marble, the marble is denser. Okay, so again, we're talking about density in terms of our liquids and also our solids that we're working with today. Okay, so that marble is heavier, denser. See, it went all the way down to the bottom. It's at the bottom now. Okay. And that, wow, looks like our bead made it down through to the soap, down and it's sitting in the soap. But our very light styrofoam ball sitting right there on top. Okay, so pretty cool. Let's look at the layers one more time. Kind of stinks that our rubbing alcohol, unfortunately, had too much water in it. Enough to make it mix with the water too. So let me show you here. It is really, okay. So I put my straw down in here, okay. Go down through, okay. But let me show you here. When I get a little scoop of water, okay, it's green. It turned green because of our rubbing alcohol was green, so it turned it into a green. So there's no more red. But so I just penetrated through all the layers here, okay. Caused a little bit of distortion, but they'll separate back out for sure. All right, I hope this experiment was fun to be a part of. I hope you can do it at home. Make sure, like I said, make sure your rubbing alcohol doesn't have a lot of water in it, or you're gonna have the same problem I had. Okay, didn't even put that into account when I used it. I thought, oh, I just have rubbing alcohol, great. But I should have paid more attention to the fact of the water, because we have talked about water and water molecules liking each other and wanting to find each other wherever they are. Okay, friends, we'll come together next week for another activity, and we're looking to go live next week. Talk to you soon.